Hi guys, this is Mr. Tupas and today we're going to talk about how to solve inequalities with multiplication and division. Now the good news is, if you know how to solve equations with multiplication and division, it's easy to solve inequalities with multiplication and division. They are very similar except for one exception. And that exception is, when you are multiplying and dividing by a negative number, you have to flip the sign. We'll discuss about that later, but for now, let me show you how easy it is to solve an inequality. Over here, I have an inequality that is being multiplied. I have 9 multiplying x, which is greater than 18. Our goal does not change. We have to isolate the x, or make x all by itself. So we will do this by the inverse operation of multiplication, which is division. So I'll go ahead and divide 9 over here. This 9 cancels out. What I do to one side of the equation, I have to do to the other side of the equation. So I will divide 9 over here. 9 divided by 18 will equals 2. I will bring down the inequality here, and of course, I will bring x here, which is all by itself. Now my final solution to the equations would be x is greater than 2. How do I graph this? Very simple. If I have a number line over here, and this is 0, this is 2, and probably this is 3, and this is negative 1, my x would be here, open circle, because this is an equal, it is a greater than, and my line would go over here, because x is greater than 2. Now, how do I check if I have the right direction for my graph? If I substitute the value of negative 1 here, is negative 1 greater than 2? Of course not. So I know that that does not go there. How about if I substitute 3 over here? Is 3 greater than 3 is greater than positive 2? Of course. So I know that my graph goes in this side. All right. I told you that we had one exception to the rule. That is, when you are dividing or multiplying by a negative number, you have to flip the sign. So now I have here, instead of a positive 9, I have a negative 9. Multiplying the variable x, which is greater than 18. Again, we still have to isolate x. So I will divide by a negative 9. Again, I'm dividing by a negative 9 because negative divided by a negative will become a positive, and I need a positive x. So this will be a positive x. I will also do to one side what I did here. I have to do to the other side. Now, negative 9 divided by 18 will give me negative 2. But then again, I said the exception. If you are dividing by a negative number, you have to literally flip the sign. This sign will be flipped. So instead of a x greater than negative 2, it will be a x is less than negative 2. My final answer would be x is less than negative 2. How do I graph this? Very simple. If I have a number line here, I have 0 here, I have negative 2 here, and positive 2 here, negative 3 here. I will encircle this because this is a less than negative 2, and I will put the line over here because x is less than negative 2. Up next, we will solve an inequality using multiplication. What I have here is an x that is divided by 2 is less than or equal to 3. Again, our goal does not change. I need x all by itself, so I need to get rid of the 2. I will get rid of the 2 by the inverse operation of division, which is multiplication. So, I will multiply this by 2. Now this will get rid of the denominator 2 and will make x all by itself. I will bring the inequality less than or equal to. Now what I do to one side of the equation, I have to do to the other side of the equation. So I will also multiply this by 2. 3 times 2 is equals to 6. And there we have it. X is less than or equal to 6. Now how do I graph this? Very simple. If I have the number line over here, I have 0 over here. I probably have 6 here, negative 6 here. I will encircle this, and this is a closed circle, which means that 6 is also part of the solution to our equation. And since x is less than 6, my graph will go this direction, and do not forget the arrow. Up next, we have the same problem, but this time I have a negative x over 2 is less than or equal to 3. How do I do this? Same rules apply. I have to still isolate the x. But since this is a negative, I have to multiply this by a negative to cancel out that negative. So I will multiply by a negative 2. Now this cancels out. But since this is a negative, I will have a positive x. And then what I do to one side of the equation, I have to do to the other side. If I multiplied by a negative 2, I have to multiply this side by a negative 2. Negative 2 times a positive 3 will give me a negative 6. And since our rule is if you divide or multiply by a negative number, you have to flip the sign. So instead of becoming an x is less than or equal to 3, I will flip the sign. And I will have an x is greater than or equal negative 6. And the final answer would be this. So again, how do I graph this? Very, very simple. If I have a number line over here, I have 0 over here. I probably have negative 6 over here. I will encircle this, and I will shade the circle because this is a closed circle. I have a greater than or equal to, that is a closed circle. So if x is greater than negative 6, my line would go over here. And do not forget the arrow. Again, how can I check if my direction is correct? If I have a negative 7 over here, and I substitute negative 7 with x, is negative 7 greater or equal to negative 6? Of course not. So that is not right. How about if I have number negative 1 here? Is negative 1 greater or equal to negative 6? Yes. So that's how I know that the direction of my arrow is going this way. Okay guys, again, this is Mr. Tupas, and that is how you solve inequalities by multiplication and division. Behind me is how I record this setup, and follow me in our YouTube channel, which is Mr. Tupas Math. Again, this is Mr. Tupas, and reminding you guys that you were born in this world to solve a problem. Become the solution in someone's life. Rock and roll.